If you are new to this channel, make sure you subscribe, like and share. Now, today I'll be taking the theorem 2 and 3 together under the circle theorem. Now, for the theorem 2, if this line is a diameter, let's say line AB is a diameter. Any angle that subtends it, as I could see here, that means ACB, angle ACB will be 90 degrees. What does that mean? That means any angle that subtends a diameter is always 90 degrees. Angle subtends a diameter is 90 degrees. It's 90 degrees. So it can come either in this form. So far this thing is a diameter. If it's a diameter, angle that subtends is always 90 degrees. That's the theorem 2. Is you have to take note of that. Now theorem 3, before we solve like 3, we are going to use this theorem 2 and 3 together to solve some questions under circle theorem. Now theorem 3 says when you have a circle, when you have something like this, if you have something like this, even if you don't have this, if you have something like this, and the label, let's say I label it A, B, C, D, circle O. What happens is that if you look at this diagram very well, these two angles, they are in the same segment of the circle, because this is major segment, and these two angles, they are in the same segment of this circle. So that means the two angles, all the angles in the same segment of a circle, they are always equal. Angles in the same segment of a circle are always equal. Angles in the same segment of a circle are always equal. That means angle BAC, this angle is equals to angle BDC. Angle BDC. Now, when I put it like this, that shows that this one is the angle. Now say BAC. That means angle form here. BDC. That angle form here. So these two angles, they are in the same segment. They are always equal. They are always equal. They subtend the same chord. This is a chord. This is another chord. They subtend the same chord in the same segment. So they are always equal. Now let's take these two theorems to solve 2 or 3 questions under circle theorem. Now, number 1 says we are given something like this. Y, X, Z. Z in the diagram. In the diagram, the XZ is the diameter. The diameter of a circle. 5/2 centimeter. Circle radius 5/2 centimeter. If XY is 4 centimeter, then the area of the triangle XYZ. Now, let's take a look at this number 1 questions for this theorem 2 and 3. Do not forget, I said angle subtend a diameter is always 90 degrees. So if this XZ, line XZ, is our diameter, that means angle that is here is 90. That means angle XYZ, angle XYZ is 90 degrees. This same represents angle. And always note that the letter in the middle is always the one that carries the angle. Now they say in the diagram, XZ is the diameter, if 2 is the diameter of a circle, radius 5/2 centimeters. That means they call this line, they said it's a diameter, but they now call it radius. If they call it radius, that means don't forget that diameter is always equals to 2 radius, 2 times r. Because I have to turn it to this radius given to me. I have to change this to diameter. If I want to change it to diameter, because this line is a diameter, I have to say d equals to 2r. And that means d equals to 2 times what they give me as radius, 5 all over 2. 2 cancel 2. That means my diameter is 5, which is this line. If my diameter is 5, then I say if xy is 4 centimeters, xy is 4 centimeters, then the area of the triangle XYZ, they ask me to find the area of the triangle XYZ. Without not talking too much, you should have known that this triangle is a right angle triangle. Because this place is 90 degrees. This place is 90 degrees. And any side that faces 90 degrees is always hypotenuse. That means you can redraw the triangle to be something like this. And this place will be 90. This place, which is our y, y here will be 90. And let's say I put my y here, my x here. So this is 4 centimeters and my z here. So, and for me to get the area, don't forget that this is diameter xz, which is 5 centimeters. Now, for me to get the area of this triangle, because if I want to calculate the area of a right angle triangle, that's for this one half in height, I can get this base. That's, I'll just use half base times height. Half base times height. That shows that I'll just say the area of a triangle is half times base times height. And I've known my height to be 4. How would I get the base? I will use Pythagoras theorem. Because it's a right angle triangle. For me to get this my base now, this hypotenuse, that's 5. Hypotenuse squared equals to opposite square plus adjacent square. That means hypotenuse is 5 squared. The opposite, let's say the opposite is the angle 4 squared. I'm looking for this base, adjacent square. That means 25. 5 squared is 25. If I bring this one here, that is 4 squared, that is 16. Minus 16 equals to a squared. 25 minus 16, that is actually 9. 9 equals to a squared. If I square root the both sides, so that means the adjacent is 3 centimeters. So that means the base is 3 centimeters. So that means the area of that triangle will be half base times height. 3 times 4. 2 here 1, 2 here 2. So that means 3 times 2, that is 6 centimeters squared. So that is the area for that triangle. Now let's take a look at number 2. I would like us to solve just 3. For this theorem, just 2 theorems. Now, they give number 2. She said PQRS is cyclic chord. Cyclic quadrilateral with PQ as diameter of the circle. If angle PQS equals to 15 degrees, find angle QRX. The diagrams looks like this. Given the diagrams, diagram looks like this. Now, this is the diagrams. It said PQRS. PQRS is a cyclic chord. At times, they may not draw it for us. When you hear the word cyclic chord, that means it's quadrilateral. It's having 4 sides. So that means if they say cyclic chord, that means inside a circle, that quadrilateral staves. So you can just draw it yourself in case it is not given. PQRS is a cyclic chord with PQ as a diameter. We all know what I mean by diameter. It divides the circle into 2. This PQ divided into 2. And diameter of the circle. It says if angle PQS is 15 degrees, angle PQS is 15 degrees. Angle PQS is 15 degrees. Find angle QRS. Angle QRS. QRS. That's what we are looking for. Q, this Q, R, S. Q, R, S. That means I'm looking for this. That's what I'm looking for. Q, R, S. I'm looking for this angle. This is where the angle forms. Now, how do we do this? If you take a look at these diagrams, if this line is a diameter, according to the theorem stated, that means this angle here will be automatically 90 degrees. And this angle, everything here also will be 90 degrees. That means angle I would write as QSP. Angle QSP equals to angle QRP. Angle QRP. That is angle subtends a diameter. Angle subtends a diameter. That's angle at the semicircle. That is 90 degrees. So those ones are equal. We should take note of that. Take note of that. After we've taken note of that, are you aware that I can also get angle QPS? This angle, I can get it. Angle QPX. You know, this thing has formed a triangle. This is a triangle. This is another triangle. This triangle now, there is a 90 here. Since I've known there is a 90 here, I can get what is in this corner. How do I get angle? That's angle QPS. Angle QPS. This angle will now be 90 plus 15. That is 105. That's 105, and because the sum of angle in triangle, that's 180. That'll be yes, 105. That's 180 degree minus 105 degree. So that is 75. That means angle QPS here is 75 degrees. Now, if this one is not 75 degrees, we should know that these two angles, this angle that is here and this angle that is here, they are in the same segment. They subtend the same chord in the same segment. This is a chord. This is another chord. That means this angle that is here is subtend this chord, and this angle that is here subtend this chord. Do not forget that theorem says the angles subtend the same chord in the same segment. They are always equal. That means angle QRS, angle QRS, which is here, we also be saying 75 degrees. Because it subtend the same chord, and which is this, and they are equal. They are equal. So that is what they asked us to find. Angle QRS, which is 75 degrees. So let's solve the last one under this these two theorems. Now the third one, we are given something like this. sorry, there's a line here, and you give 40 degree here and 40 degree here. W, Y, it give us 30 here, and T, Z, X. I think that was. They say in the figure, the chords X, Y, and Z, W are produced to meet at T, such that YT equals to WT. Equals to 40 degree, and equals to 30 degree. Then what is W, YXW? I'm looking for this. Now, let's take a look at this as the last one for these two theorems. They said in the figure here, the chords XY, as you can see, this one is a chord. Don't forget, you're going to divide this circle into two unequal parts. The chord and the ZW is also another chord. Are produced to meet at T. They extend them to meet at T. Such that YT equals to WT. They say YT. That means this line is equal to WT. YT is equal to WT. What does that mean? If these two lines are equal in this triangle, because this one is another triangle here, triangle W, this TYW form a triangle. But if these two lines are equal, it tells you that these base angles should be equal. That's so that this triangle is an isosceles triangle. And you know what I mean by isosceles triangle. The two base angles are the same. They are the same. So they now say that YT equals to WT, like you said, and angle ZYW, which is Y, is 40 degree. ZYW is forming 40 degree. And YTW, angle YTW is 30 degree. What is angle YXW? We are looking for YXW. We are actually looking for this. We are looking for YXW. So how are we going to get that? How are we going to get that? If you can open your eyes clearly and see, you will discover that they say this one is isosceles triangle, fine, and these two base angles are equal. That means if this is 30 degree, you know, the sum of angles in triangles is 180. If I remove 30 from 180, that's actually 150. And if the remaining is 150, that means these two angles must be equal. If you divide 150 by 2, that is 75 degrees. So that means here is 75, here is 75, because they say these two lines are equal. And if this is 75 and this is 75, if you look clearly, you will discover that this is another triangle. You can see, trace it here. This will form a triangle. It forms a triangle. That means if it forms a triangle, that is triangle T, Y, Z. It forms a triangle T, Y, Z. And that triangle T, Y, Z, this is 30 degrees. Angle YTW, YTW give me 30 degrees. This one give me 30 degrees. And this one now, for this whole triangle that I form here, if I add this one, that means angle T, Y, Z, angle T, Y, Z, that would be 40 plus 75. 40 degree plus 75 degree. That is going to give me 40 plus 75, that is 511. That is 115. So if this one is 115, so I can get the remaining here. Do not forget that the sum of angle in the triangle is 180. That means 115 degree plus 30, 541. That is 145 degree. So 145 degree, if I remove it from 180, 180 degree minus 145, that is 5, that is 35. Definitely this guy will be 35. Angle Y, Z, T. Y, Z, T is 35. I hope you are getting this, because this is 30. They said these two base angles are equal. When they are equal, so what do I do? This form another triangle here. So this is 30. I just add these two together, and I added these two. I removed it from 180 to get this third side of the triangle, and it gave me 35. Now, without wasting our time, and we are looking for this initially. What is these two angles? They are in the same segment. They are in the same segment, and they must be equal. So that means this angle I'm looking for is also 35 degrees. I'm looking for angle Y, YX, W, which is also what? 35 degrees. Angle in the same segment of a circle are always equal. That's giving me 35 degrees. So I'm going to stop the theorem for today here. So when next we meet, we continue with the theorem. Theorems are many in mathematics. Theorems are many in mathematics. We just started. And please, you have to just stay. And in case you have any comments, like to drop, like you have a place that is not that clear to you, you can drop it on the comments list, and I'm going to attend to that.